Okay, so we filled in our Venn diagram. We put all the evens in one circle, all the primes in the other. 2 is both, so we put it in the middle where the two circles meet. 1 is a possible outcome. It just doesn't fit into either one of those circles, so we stuck it here on the outside. Okay. Now that we filled in our Venn diagram, we can talk about the union and intersection of two sets. Okay. The union of two sets is pretty much taking two sets and combining them as one big set. You're taking everything in both and combining them to one set. Okay, we often associate union with the word or. So if you see A or B, this or that, that's talking about the union of two sets. It's often used this notation, that U shape, that U symbol. How I like to, when you see that notation, to me that means union, because union starts with U. Okay, that's just math language, that U symbol means or. Okay. One way of looking at it, the union is what's in both circles of a Venn diagram. It's what's in both sets, combined as one big set. The intersection of two sets is associated with the word and. Okay? The symbol in math that we sometimes use, it looks like an upside down U or a lowercase n, how I like to look at it, because and or intersection both have an N in them, have that N kind of sound, that looks like an N. So when you see that N shape, or N lowercase n symbol, that means intersection, or and. And that part of the Venn diagram, it's what the two sets share, okay? Meaning what repeats in both sets. In terms of the Venn diagram, it's the middle. The middle of the Venn diagram. Literally where the two sets intersect in a Venn diagram is the intersection. Like what they share. Okay. Questions over here? So let's take a look at this example. We're going to write out the following two sets. So from the first example, we put everything in a Venn diagram. This one we're going to write it out. So we're going to write out all the elements for A or B, the union of the two sets. So A or B, that set is equal to. So essentially what we're doing is combining the two sets together. So we're literally naming every single number that are inside all of those circles. So what's going to fall in to the union of these two sets? What are all my numbers that are inside those circles? What's one number? Let's go in numerical order, so it's the littlest number. 2, what's our other number? 3, what's another number? 4, 5, 6, 7, 8. Those are all the numbers that fit inside those sets. You're literally taking the two sets and combining them as one. So we're listing all the numbers. 2, 3, 4, 5, 6, 7, and 8. We're not writing 1 because 1 was not inside either of those sets. So it's not going to be in the union of those two sets. Okay? It wasn't inside our circles. The intersection, so A and B, is what the two sets share. Well, what number did they share? 2. So their intersection is 2. The only thing that they share. Okay. From part A and B, why is this equation not true? Okay? The number that's in their union, why does it not equal just the amount in both added together? Because you're combining the two sets together, so wouldn't it make sense if we just added the amounts in both sets, we would get what's in their union? Let's see why that doesn't work. Okay? So let's take a look. We said how many, when we wrote out their union, how many elements were in that set? How many outcomes? How many total? 7, right? we're going to see why why that's not equal to just adding the two sets together. So if I take a look, how many, I look at just the even circle, how many fall into that circle? How many are in set A? Yeah, there's 1, 2, 3, 4 outcomes that fall into set A. So I'm going to put 4 plus, go back to our Venn diagram, then the amount that's in B. So I just look at the B circle. How many elements are in B? 4. Okay. And 4 plus 4 is 8. Yeah, 7 does not equal 8. Why is this not true? What happened when we counted up the amount in both sets? Well, 1 isn't in either set, so 1's not going to be included. 1 wasn't in the union, 1's not in either set, so we can't include the 1. You're on the right track. Yeah, we counted 2 twice. We counted it. It falls in set A, so we counted up all the elements in set A. We counted it once there. 2 also fits in set B, so when we counted the amount in set B, we counted it a second time. We counted one thing twice. Okay? So there's something that we have to do to this formula to make it true. Okay? So to figure out the amount that's in the union, you're still going to add the 2 sets together. But we have to subtract something from this. Okay? And what we're going to subtract is the intersection. Because that's what we counted twice. When we looked at our Venn diagram and counted, when we counted our sets, we counted what was in the intersection twice. So to get rid of that double count, if we just subtract the intersection, then we're taking care of those doubles, those repeating numbers we counted. Because now if we did 7 is equal to 4 plus 4 minus, how many were in our intersection? Well, how many outcomes were in our intersection? There's only one number in our intersection. It happens to be 2, but there's only one number. Now when we do this, 7 is equal to 7, because 4 plus 4 is 8. Subtract the intersection to get rid of that repeated number. Now we get the right amount. We have to subtract the intersection to get rid of those repeating values. So we double count. Because they're in both sets, so we double count. Questions over that? Okay. This concept applies to probability, because we're going to be asked what's the probability of one event happening or another. Okay? Oh, and this should be a B, not an A, B. That should be B. So the same formula applies. They used to not give you this formula. So I didn't give you this formula because you were expected to know it on the OST, but they now put it on our reference sheet. Okay? So we can now use it. I'm not going to give it to you. So you don't have to memorize this formula. You used to have to, but now you don't. So you're going to have it on quizzes, you're going to have it on tests, you're going to have it on your reference sheet, okay? So you just need to know when to use it. And you know when to use this formula? Oh my gosh, my smart board. When you see the word or. When you see the word or. I don't want your calculator. I want your test. Have a good weekend. Thanks. Okay, when you see the word or, you should automatically be thinking, I need to use this formula. How I like to think of the formula, it's probability of the first thing plus the probability of the second thing minus probability of both things happening. Okay. Whenever you see the word or, we're using this formula. So we'll take a look at some examples of it. In example 3, it says a small high school surveyed 52 of its seniors and their plans after they graduate. They found the following data and wanted to analyze it based on gender. In this case, if we pick a student at random, we can place them into one of 4 events. Okay? M stands for male, F stands for female, C stands for going to college, and N stands for not going to college. So we're going to use this table to find the following probabilities. Right? We want to find the probability of N. So the probability of not going to college. What's going to go in the bottom? 2. Yeah, very good. The total goes in the bottom. There's 52 seniors. Of those 52 seniors, how many are not going to college? 23. You can totally leave it like that, but just for practice sake, if we ever need to do this, what's 23 over 52 as a decimal? Just divide them. What is it? 0.44? So 44%, 23 out of the 52 of those students are not going to college. Just the basic. B is saying what's the probability of F and C? So what's the probability of picking someone who is female and going to college? They have to fit both criteria. Okay? So we're still going to make a fraction. What's still going to go in the bottom of our fraction? 2. People there were. So we have to figure out of those 52 people, how many are both female and going to college? How you can figure this out in your table, you just go to where those two categories intersect. So you put your one finger on female, one finger going to college, go to where they meet. And they meet at what amount? 13. So 13 out of the 52 are both female and going to college. Again, for practice sake, what is that as a decimal about? Or it should be on the nose, actually. 0.25. So that means 25% of those 52 people are female and they're also going to college. They're both. C is saying find the probability of picking a person who's female or going to college. Okay. I see the word or. Okay. And is where they meet on the table. Or is telling me I need to use this formula. Whenever you see the word or, you are using this formula. So let's write it down in relation to this particular scenario. Okay. So probability of or is equal to the probability of the first thing, and the first thing they gave us was female, plus the probability of the second thing, which is going to college, minus the probability of both female and going to college. Again, you will have to use that formula. You just have to know how to use it. Okay? And I just think first plus second minus both. First plus second minus both. Okay? So we're dealing with probability. So I'm going to put a fraction for each of those probabilities. And it's going to equal a fraction. So I put fraction bar plus fraction bar minus fraction bar equals a fraction bar for my answer. Okay? So I'm putting a fraction bar for each probability. And then one that my answer is going to equal. What's going to go in the bottom of all these fractions? 52. That's the total for all our probabilities in this scenario. They're all out of 52. Even your answer is going to be out of 52. All your fractions, the total goes in the bottom. Then you have to fill in the total for each kind of event or category in the top. So probability of female, how many total females are there? 22. Alright? Probability of C, going to college, how many total people are going to college? 9. Minus how many did we just say were both female and going to college? Where do they intersect on the table again? 13. What's nice about this, we're combining fractions that have the same exact denominator. So you literally just have to combine the tops. When you have a common denominator, it stays the same throughout. So in your calculator, all you have to do is just do 22 plus 29 minus 13. And we get 38. So 38 out of the 52 people are either female or they're going to college. They're one or the other. Just for practice sake, what is 38 over 52 as a decimal? 0.73?
Yeah.
About 73% of the people are either female or going to college. Or one or the other. Questions over that? One more. We'll finish up the last example on Monday. So warm up. Or we'll try to get through it. This one we fell on. At a local animal shelter, there are 420 dogs that have been rescued. Of those dogs, 230 are Labradors, 300 are female, and 205 are both Labrador and female. If a dog is adopted at random, what is the probability of picking either a Labrador or a female? I see the word or. I need to use that formula. Okay? That formula is probability of the first thing. What was the first category they gave us? Labrador. Yeah, we're dealing with dogs. They said there's 420 dogs. Of those dogs, we have labs. Plus, what other type of dog do we have? What other category? We have labs and we have what? Female, right? Those are the two categories they gave us. They gave us labs. They told us female. Minus both, being a lab and we abbreviate female with an F. Whenever you see the word or, you're following that formula. First plus the second minus both. And you have the formula. You don't have to memorize it, you just have to know when to use it. Again, we're dealing with probability, so I'm going to write out my fraction bar for each category. Labs gets a fraction bar, female gets a fraction bar, both get a fraction bar, and our answer gets a fraction bar. The total for the entire thing is going to go on the bottom of all those fractions. What was our overall total? 420. There are 420 total dogs. So 420 goes on the bottom of each fraction. Then you put the totals for each thing in the top. How many total labs did we have? 230. How many total females? 300. How many total were both? So again, we already took care of the denominator. Just combine the numerators. 230 plus 300 minus 205, and we get what? 3 what? 325? So 325 out of those 420 dogs were either a lab or female. One or the other. What's that as a decimal just for practice? Point what? That's 325 divided by 400. So 0.77. So 77% of those dogs were either lab or they were female. Questions over that? So, for the next example, it says an insurance company typically tries to sell many different policies to the customers. At one such company, 56 of all of the customers have car insurance policies, and 48% have home insurance policies. So 86% of the customers have either car or home insurance. Find the probability that a customer picked at random will have both car and home insurance. So this is slightly different because they told us what are or what. The board's a little disoriented. Okay, I still see the word or in my word problem. Okay, so I'm still going to use that formula at the top of your notes. Okay, the probability of A or B, in this case, the two things we're dealing with are insurance, and those types of insurance are car insurance, so probability of car, or home insurance, if I can spell. All one thing? Okay, almost scooted over. Probability of car or home insurance is going to be equal to probability of the first, so car, plus probability of the second, home, minus probability of car and home. This time around, they told us what our OR was. They said 86% of their customers have either car or home insurance. They told us what our OR was. We want to find this time around the and. We want to find how many have both car and home insurance at this company. Okay? Well, let's fill in our numbers. Whenever you're given percents and we're trying to solve, write them as decimals. So the amount that had car or home was 86%. So if you divide that by 100, that gives you 0.86. The OR is equal to car. Well, 56 had car insurance, so 0.56, plus 48 had home insurance, 0.48, minus, we don't know how many people had car and home, so I like to put X for there. If I don't know what it is, I just put X. And then we're just solving this like an equation. So this is 0.86 is equal to 0.56 plus 0.48, 1.04 minus x. To get x by itself, move the 1.04 over. So we get negative x is equal to, when you combine that into your calculator, you do 0.86 minus 1.04, you get negative 0.18. Okay? It's okay to get a negative because technically there's a negative in front of that x. So to get rid of that negative 1, divide by negative 1 on both sides, that leaves us with x, and negative 0.18 divided by negative 1, positive 0.18. And when you convert that back, you can multiply by 100, and that would give you 18%. So 18% of that company, of their customers, they have both car insurance and home insurance. So sometimes you have to work backwards, and that is okay.